While this is not the last example in this section, it is going to be our last example for today. This last bit we may have just stumbled upon in the scientific notation quick check, but we noticed that we were left with an exponent of 0. Let's look at another example. And this you can see on page 582, 3 to the 5th over 3 to the 5th. Now again, let's expand that and see what we are left with. 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. Now I want you, before we go on with the notes, to take a second and make a hypothesis. What do you think is going to be simplified? This is going to be simplified too. Now that you've made your hypothesis, I want you to take a look at another problem, or just think about another problem. If I were to divide any number, for instance 100, by itself, 100 divided by 100, what would it equal? What does that simplify to as a fraction? Now let's think about our example up here. Anything divided by itself is what? Let's keep that in mind. I'm going to go just like I did at the beginning and simplify factor by factor. 3 over 3, I can simplify to 1 over 1. Again, 3 over 3 simplifies to 1 over 1. 3 over 3 is 1 over 1. Another one, 3 over 3 is 1 over 1. And 3 over 3 is 1 over 1. Now, when I go to say, what is this equal to? Well, there are no more 3's left. 1 times 1 times 1 times 1 times 1 is simply 1. Same thing, 1 times 1 times 1 times 1 times 1. And when I simplify 1 over 1, it is 1. Now, we saw our rule at the beginning was that we can subtract exponents. 3 to the 5th over 3 to the 5th has the same base, 3 to the 0 power. That's 5 minus 5. That's from our rule at the beginning. We also just found that 3 to the 5th over 3 to the 5th is equal to 1. And in fact, this is true. You can see this at the bottom of page 582. Any non-zero number a to the 0 power equals 1. That's true for any base as long as it's not 0. Anything to the 0 power is 1. And it's because of this right up here. All of those factors cancel out and we're left with 1. So let's try it. We said anything, this is example 3 now. We said anything to the 0 power is 1. So what about negative 8? Negative 8 to the 0 power is still 1. And that negative sign inside parentheses means that is part of the base. If I'm not sure about that negative sign, I can come over here in my calculator. Anytime I have parentheses, I know I have to put those in my calculator. My calculator likes to do that negative last if it can. And then to the up arrow, 0 power is positive 1. Same thing when I have some factor. 3m to the 0. This is a second example. You'll notice this is example 3b. This is 3a. Notice I don't have parentheses now. So what is the base? Well, the base of the power is actually just m. I could rewrite this as 3 times m to the 0 power. Anything to the 0 power, even variables, are just 1. So this simplifies to 3 times 1, or 3. Now, as we look ahead on Thursday, or in the next set of video lessons, we're going to look at what happens if the base is the whole thing, 3m. But for that to be true, we would have to have parentheses. Try quick check 3. You can try all 3 parts of that, A, B, and C. Pause the video if you haven't and try those. Okay, 3a, negative 9 to the 0 power. As always, anything to the 0 power is 1. Part B, 2r to the 0 power. Like I said, we'll talk more about the product, but if I know this is all to the 0 power, well, then it's equal to 1. And part C, now I have 2 times r to the 0 power. R to the 0 power is 1, but it's multiplied by 2. So this equals 2 times 1, or 2. We will continue with part 4 on Thursday. So notice there is more to this section. We will continue that on Thursday, along with the extension you will see after this section. Give it some practice on the suggested problems or the homework problems you'll see on RenWeb and Moodle, and I will talk to you soon.